Alright, to finish this problem, there's a couple different things that we have. First of all, number 14, notice it says that angle BDA is a straight angle. In other words, BDA is this line that goes all the way across, and the definition of a line is just a 180-degree angle, right? It's a straight angle. So what they're telling me is that if I went from here, for instance, and I made, let's say I made one angle, and I went from here all the way across, that would be 180 degrees. That's what a straight angle is. Now notice they didn't give us a number because they want you to have that memorized, that you understand a straight line forms a 180-degree angle. Although notice that within this 180 degrees we have another angle that cuts through the middle, and they're giving us the measures of those angles as an expression rather than a number. So for instance, this is negative 8x plus 48 degrees, and this is negative 7x plus 12 degrees. Now with this information, they want us to find angle BDC. So I'm going to highlight that one yellow. So they said find BCD. So they want us to find this angle right here, BCD. And just as they want us to find that angle, I'm actually going to go ahead and highlight it. We know that it's going to have to be less than 180 degrees because it doesn't go all the way around. It's just part of it. Now they give us this expression here that we can use, but before we can use this expression to find this angle, we need to go ahead and solve for x, and then we can substitute that value in. So what I'm going to do is I'm going to take the information they have given us. For instance, I'm going to take this one right here. It says negative 7x plus 12. So negative 7x plus 12. And then I'm going to go ahead and add it to my second angle. And my second angle is going to be this negative 8x plus 48. So I'm going to go ahead and put that in parentheses, negative 8x plus 48. The reason I'm putting the second one in parentheses, in case you're wondering, is because we do have a negative sign in front of that 8, and I don't want to forget to distribute, right, and change this whole thing to minus. So I'm going to go ahead and just write it like that for now. And then what I'm going to do is I'm going to say that this is all equal to 180 degrees. How do I know that it's equal to 180 degrees? Because I was told that BDA, that's B, D, and A, form a 180 degree straight angle. So now what I want to do is I'm going to go ahead and do some math here. Now if we were to, when I say distribute, this, remember there's always an invisible 1 in front of every parenthesis, so this positive sign, distribute it to the negative, it just makes it negative 8x. And you know what I think I'm going to do when I rewrite this? I'm going to put my constant values in red, and I'm going to put my variables in black, just to help me not mix these things up. So this is going to be negative 7x, and then we have plus 12. Okay, so now we wrote it, right? And if this confused you, write in the parentheses, well, just leave the parentheses off, right? Just write what's on the inside here and just write it all out, because that's what I did here without the parentheses, right? So now what I want to do is when I'm solving an equation, if you forgot about how to solve equations, on one side of the equal sign you want your constant value, and when I say constant, it just means you don't want to have a variable, so there's no variable. And then on the left side of the equation you want your variable. So just remember, on the left side you want the variable, on the right side of the equal sign you want your constant. Now I'm going to go ahead and we're going to start doing some math. I'm going to start by just drawing a line through my equal sign, because we're going to be moving things over, right? We have to move both of these constants over, but I recommend before you move them, combine your constants. The sign that's in front of the number goes with it. Like in other words, if this was minus 12, that minus sign or negative sign would go with it. But because it's positive, the positive sign goes with it. So we have a positive 48 and a positive 12. Now we do want to put those two values together. I'm going to use my Desmos calculator over here to make sure I don't make any calculating errors, and I recommend you do the same thing. So we have 12 plus 48, and that gives us 60. So my constant value is 60. I'm still going to bring down this 180. We're going to deal with it in just a moment. And then I'm going to put my variables together. I want you to notice I got a negative 8x and I have a negative 7x. So we're going to put those together real quick. So in other words, when I say put them together, we're just going to take the number in front of the x and put it in the calculator along with this one. And we're combining them, so we're actually adding them together. So negative 8x plus negative 7. And so I'm not going to put an x though, I'm just going to do negative 8 plus, oh, well, you know what, let me go back. I forgot to take those out. Negative 8 plus negative 7. So right, negative 8 plus negative 7. That's this negative 8 plus that negative 7. Enter, and it gives me negative 15. So my variable, I actually have negative 15x. So while we have a positive 60, we have a negative 15x when it comes to the variable. Now that I've combined my two constant values and I combine my two variables, I want to take this constant value of 60 and use the inverse operation to move it to the right side of my equal sign. So 60 minus 60 is 0. 180 minus 60, well, I'm going to put that in the calculator. 180 minus 60. And notice it gives me 120. So this becomes 120. I'm just going to continue bringing my equal sign down. That line just represents the equal sign. And I'm going to bring my variable over. The only thing I got left on the left side of the screen is the negative 15x, which is what we wanted. We want the variables on one side and all constant values combined and put on the right side. So we have negative 15x on the left and we have 120 on the right. Now my next step is I want to get rid of this coefficient in front of x. We want a coefficient of positive 1. So the way I get rid of that negative 15 is I have to divide it out. And I must divide it out on both sides. So I'm going to cross it out. Anything divided into itself is 1, so I'm just left with x is equal to, and I'm going to see how many times can negative 15 go into 120. So I'm going to type in 120 divided by negative 15, and that's going to give me negative 8. So I know my x value is negative 8. Now we are not done. I'm going to circle it. I'm not going to box it, but I'm going to circle it. We are not done. We must take this negative 8 and substitute it in place of x in this expression, negative 7x plus 12, in order to find out the value of this angle before we can go ahead and give an answer. So I just put my little angle sign. We're about to figure out what this is. Now I'm going to do that over here on the left. So we have negative 7x plus 12. So I got negative 7. I'm going to put my x in red. X and then plus 12. The reason I'm doing the x in red this time is because we're going to substitute a value for x. What's the value? Well, we found that x was equal to negative 8. So in order to evaluate this expression, I want to go ahead and I'm going to replace that x with a set of parentheses and a negative 8 inside, because that's the answer we had over here. I'm still going to bring down my negative 7 and bring down my positive 12. So now, instead of having negative 7x plus 12 for our angle, we actually have negative 7, parenthesis, negative 8, close parenthesis, plus 12. Now I'm going to put all this in the calculator, and I'm going to see what it gives me. So in other words, we're evaluating that expression. Negative 7, parenthesis, and the parenthesis just means to multiply, negative 8, close parenthesis, and then plus 12. And let the calculator do all the work, and it gives me 68. So I know the answer to this is 68 degrees. So this angle inside of here is 68 degrees. So I want to find the measure of BDC. So I'm going to put the measure of angle BDC is equal to 68. Alright, let's go ahead and do the next problem. I am going to go ahead and just block this off real quick in case we need to use some space to do some more calculations, so we don't get confused about what belongs to what. Now in number 15, it says in the diagram DC bisects angle BDA. Find the measure of angle ADC. Okay, so I'm going to highlight it. ADC is what I'm trying to find. And it did tell us that DC, right, and it's a ray. Notice that it has an endpoint and it has an arrow on the other end. So this ray DC is going to bisect BDA. BDA is her other angle. So let's go and find BDA. So this is B, D, and A. So BDA, looking at it, right, it looks to me, I mean, it doesn't say it is, but it looks like it's somewhere around 90 degrees, right? Because of the way this looks like a 90-degree angle, but it doesn't have the box signifying that it is. But what we do know is that DC is going to bisect it. It's going to cut it in half. So I'm going to go ahead and I'm going to find angle ADC now. That's the one we're actually trying to find. So ADC. So we want to find this angle right here. So we are trying to find what's inside of here. We don't want to know the whole angle. We just want to know what this angle is, this one angle. Now the neat thing about a bisector, when it says it bisects BDA, so the whole angle, it means that it's half of it. I want you to think about a bisector, it's similar to a midpoint. Like on a line, if we had something that was linear and we said find the midpoint, you would find the distance in between it. But when we bisect an angle, we're cutting it in two equal parts. And so you could think about it with the same idea. It's halfway between the total angle. In other words, if I made one total angle all the way around, this part right here that's orange is exactly 1/2 of it. The reason this is very important to understand is because we're going to need to find x again and substitute it in. But we can't do that without knowing that this is a bisector and that this represents half the angle. Because if it's half, then we can add this other side of the angle to this side of the angle and have one whole angle. Now I'm going to go ahead and highlight real quick another section, right? In other words, this whole angle right here, this is half of it. So what I'm going to do is, since I know that this is arrows point right here, and what that arrow is basically saying, I'm going to use my other color pen, they're saying that this angle right here is 7x minus 19. And we already know that this one down here in the orange, right, this one was already 9x minus 37. So what I'm going to do is I'm going to set this angle equal to this one. Why? Because each one of them represents half of a total angle, even though we don't know what that total value is. So I'm going to write this out. For the first one, I'm going to write it in pink. I have 7x minus 19. So 7x minus 19. And we don't know what this total angle is, so we can't assume that it's 90. We're just going to say that we know that 7x minus 19 is half the angle. So we're going to say that it is equal to its other half, which is 9x minus 37. So I'm going to write that in red, 9x minus 37. Because each one of these represents a half of an angle, I can set them equal to each other because they have to be the same distance. Now what I'm going to do is I'm just going to go ahead and change my variables to black. And we're going to go ahead and move all the variables to the left and move all our constant values to the right. And then we're going to solve it. So I'm going to go ahead and take a look, and I see this negative 19. Well, I need to do the inverse operation. So instead of subtracting 19, I'm going to add 19 so that it zeroes out on the left. I'm also going to add 19 to the right. And so I have negative 37 plus 19. So negative 37 plus 19. I'm going to hit enter, and it gives me negative 18. So this is negative 18. And then I'm going to go ahead and move my 9x, my variable, to the left. Because remember, we always want the variables on the left side of the equal sign, constant values on the right. So negative 9x. And I got 7 minus 9. So I can do 7 plus negative 9. And that's going to give me negative 2. So this becomes negative 2x's. So I got negative 2x on the left, negative 18 on the right. So I've separated my variables and my constant value. And so what I want to do now is get rid of this coefficient of negative 2. And the way we get rid of that is we simply divide by it. So divided by negative 2, divided by negative 2. And I end up with x is equal to, and we're going to put this in a calculator, negative 18 divided by negative 2. Notice it changed to a positive 9, and that's because, remember, a negative divided by a negative, or a negative times a negative, either way, is going to end up giving you a positive number. So it just changes to positive 9. Now we are not done again. What we did is we found the value of x, but we don't actually know what the angle is. So to find the angle, we want to find this orange one, right? Angle ADC. We're going to substitute the value of x in place of the letter x. So I'm going to do the substitution on the left. So I'm going to rewrite 9x minus 37. The only difference is I'm actually going to write the x in red because we're going to be substituting it with the value of 9. So 9x minus 37. And then we'll just go ahead and rewrite this, but now we're going to substitute for x. So I'll have 9, and then in place of x, I'm going to put 9 in a parenthesis, and then minus 37. And we're just going to put this all in the calculator and see what it gives me. All right, so I have 9, parenthesis, 9, close parenthesis, minus 37. And remember, we always put parentheses whenever we're substituting a number for a variable. Always put it in parentheses. So 9 minus 37, hit enter, and it gives me 44. So I know that that angle right over here is 44 degrees. And so what I'm going to do is the measure of angle ADC. So the measure of angle ADC is equal to 44 degrees. And see, good thing we didn't try to do something where we set this to 90, because even though this looks like a 90-degree angle, it's not. If I were to multiply 44 by 2, this angle right here would be 88 degrees. So it was really close to 90, but not quite. Let's look at our next problem, number 16. Move this up. I am going to draw a line across to kind of break this up to separate it so we don't get anything mixed up. It says which statements about the diagram are true. Okay, so we have 4 different statements. We want to know which ones are true. So we're going to just monitor. We're going to look at them and try to figure that out. First, it says plane KCW. So I'm going to highlight some things. And plane CHK intersect at K. So they intersect all at K. Well, let's see if that's true. I'm going to highlight the planes. So I got KCW. So there's K, C, and W. Now, you can name a plane by just giving 3 points of any plane. So what I'm going to do is I'm going to highlight it. So that plane, right, that whole area, that's my plane for KCW. And then plane CHK, so let's see. So here's C, and there's H, and that's K right there. So I'm going to highlight these. CHK. So those 2 planes, they do intersect each other. And it says that they intersect at K.
So this one is false, because while they do intersect at the point, you actually, 2 planes intersect at a line. So in other words, they should have said KC, line segment KC. So therefore that makes it false. It would be true that the line intersects. In other words, if they said WK and UK intersect at K, that would be true. But because we're talking about those 2 different planes can only intersect at a line. So that's why this one is false. So while it does contact K, it is a false answer. So make sure that you note that as false.
Next, it says N is coplanar with plane YDU. Okay, so let's look. Where's plane YDU? Here's Y, here's the D, and here's U. Okay, so it's this same one. YDU is just going to be this orange one. And it says N is going to be coplanar with it. Now, coplanar means that it lies within that plane. So we got to figure out, is N inside of this plane right here? And N is actually up here. So N is not inside of this plane. It's inside of this plane up here in the top. So that one is going to be false. Next, it says C is coplanar with plane YDU. Okay, so let's look. Plane YDU, we already established that's that bottom plane. And let's see, can we find the point C in this plane? And there's point C right there. So that happens to be true. Next, it says line segment CD and line segment CN intersect at C. Okay, well, let's see. So we have two different situations here. I'm going to go ahead and find CD and kind of use my pink pen to highlight it. So let's see, let's find CD. So here's CD. I'm just going to kind of highlight it pink coming across. And then here's CN. I'm going to highlight it with my black pen, CN. So let's see, CN is right here. And it says they intersect at C. Okay, I would say that that's true, right? Here's C right here. And notice CD and CN, they both intersect, right, and form a vertex. So that would be true.